Hello, everyone, and welcome to the GIS for Bridge Inspection and Management Seminar. We're very glad you're here, and we're looking very much forward to our panelist speakers. Before we get started and before we kick things off, let's run a quick demographic poll. Hopefully in the next few seconds, you are going to see a poll pop up on your screen. There it is right there. If you wouldn't mind, please take a few moments to fill out the poll. Tell us a little bit about what organization you work for and who and where you are. And then before we introduce our first speaker, we'll go over those results and kind of share who we are and who we represent. So while you're filling out that poll, I'd like to introduce myself. My name is Tony Spicci. I'm the Executive Director of the GIS Certification Institute, and I've been in that role for a few years now. Prior to that role, though, however, I spent over 30 years of my career in state and local government. And so I'm really looking forward to today's seminar because I think it's really going to hit home for a lot of us. We have a really great lineup in this series, and we have a really great lineup today. So we're gonna work our way through those speakers here in a few minutes. However, before we get started, I'd like to take a moment to show you the results of our poll. So if you haven't voted yet, please do that as soon as you possibly can. So looking at our speakers real quickly, it looks like we have the vast majority of the folks are joining us here from the United States. It looks like we have a couple of friends from Canada, Africa, and Asia. So welcome to all of you. Most of our folks, about 65%, are coming from local government, another 10% from state. So the vast majority of our folks are government folks, which isn't surprising. But it's nice to see a few folks from the federal government, academia, industry, and the other category. Our business sectors, we have a lot of folks in public administration and planning, transportation, public information, as well as public works. So again, kind of what we'd expect, but a lot of our friends are joining us from other categories. And then it looks like we have a pretty decent mix of participants. About half of you are from large organizations or cities of over 100,000 folks, but the other half are from smaller towns and smaller localities. So it looks like we have a really great balance, really good audience, and so welcome to all of you. So let's go ahead and get started with our first speaker. I'd like to introduce Marc Goldman. He is our first speaker. Marc is the Director of AEC Industry at Esri. Marc, I'm going to let you take it over.
Thank you so much, Tony, for the brief intro. Thank you, Bad Elf, for the opportunity to be here today with a great lineup of presenters. As introduced, I'm Marc Goldman. I'm the Director of AEC Industry Solutions at Esri, and I have the great role, I think, of being a storyteller, hearing about the great things our customers are doing at the intersection of GIS and various AEC technologies. One of them is on this webinar. He'll be here next behind me. I've been with Esri for about 5 years, and it's interesting how the understanding of GIS ranges from those who just have an inkling of an understanding, maybe something they learned about when they were in school, to those who are using it on a daily basis. So I'm going to start out here and give an overview of the capabilities as it pertains to construction and maybe a few other sectors. So hopefully you're seeing my screen now. And what I'm going to show is from a story map collection. ArcGIS Story Maps is a capability, a product, an offering from Esri. This is a collection of various story maps that we put together recently for a conference. And as I was looking at the agenda today and realizing who we were going to have connecting, I thought this would be a good starting point. And I can share this URL at the end. Specifically, I want to show this story map that's related to GIS for construction, given the topics that we're talking about today: construction inspection, asset inspection, related to bridges. We'll see some bridges here. We'll see some other elements of horizontal construction, some vertical buildings as well. And I think this will kind of level set what GIS is as it pertains to architecture, engineering, and construction. I mean, first, this statement here at the top, construction, you could probably extend this to engineering, architecture, and even asset management, is inherently a spatial process. Everything has a location. Everything gets planned, designed, built, eventually operated somewhere. It's kind of an obvious statement, but it's one that points back to the fact that GIS, Geographic Information Systems, is very location-centric. GIS is made up of layers. Layers can start out with a base map. In the case of Esri's ArcGIS, we deliver out of the box about a dozen different base maps. This one you can just see as this kind of simple, basic, dark background, and we're zoomed in on Building E, which is a recently built building on the Esri campus. We've got about 20 buildings altogether in Redlands, California. The layers that make up a custom GIS map often include points. So in this case, on this particular construction site, these various points represent trees, or they represent an entrance to the site, or they represent, in this case, a hazard. And these points get collected through various mechanisms, and I think we'll hear about those in the presentations that follow mine. Certainly, GIS maps include lines. In the case of built world projects, often those lines are utilities. So in this case, with the blue lines, are water lines. And this data comes from various sources. It could be the utility company themselves. It could be a survey that gets conducted. It could be CAD data, which we'll get to in just a second. GIS often is polygons, shapes that identify, in this case, it's a construction site, laydown areas, exclusion zones. And again, these are more than just objects that show up on screen. They've got properties. And then, as I mentioned, CAD data. And this is, I think, where GIS is probably different in a lot of people's minds today than it was even, say, 5 years ago. The intersection of CAD and also BIM data, reality capture information, survey data, all being very easily manipulated and understood in a single environment is bringing GIS into the world of engineering and construction much more so today than it just was a few years ago. Reality mapping. The idea of understanding your context through satellite imagery, fixed wing, helicopters, drones, even terrestrial scans, and being able to use that data to help provide a deeper set of context over which you might include other layers of imagery, those lines, arcs, and circles and points, or even BIM information. So in this case, this was a Revit-based model brought in into the site, geolocated, and all of these objects that at one point were in a BIM authoring tool brought into the GIS environment, into ArcGIS Pro, still include all of the properties that you would expect to see in a BIM application. But they're, in this case, available for spatial analysis, for visual analysis, for comparison, for distance, for all types of analytics capabilities that GIS delivers quite uniquely. Beyond the basics of just bringing together layers of information, GIS is very much a field operations platform as well. And I know we're going to get into more of that through the examples from some of my co-presenters here. The idea that you would go out with your mobile device, whether it's a laptop computer, an iPad, a phone of various formats, whether it's an Android device or a Mac OS device, and collect data in the field that represents the conditions of your construction project, the hazards that you have identified, or perhaps asset tracking, asset mapping, or just being able to wayfind yourself to the assets that you have found. GIS definitely includes a connection to the sensors and the equipment out on the site to help enhance awareness of the conditions. In this case here, we've got an example of a project developed by HNTB. The New Walk Bridge in Norwalk, Connecticut, an old lift bridge being replaced by a new bridge, sensors placed on that bridge to identify the conditions of the construction site as piles were being driven, reported back into a dashboard so that the construction management team would have a feel for the level of safety or lack of safety that was being created by their own construction, being able to keep this old bridge operating during the situation of construction taking place. And all this comes together to act as a means for better decision-making, whether it's at a macro scale of all the projects, all the bridges, all the roads, all the buildings that might be within a particular owner or a construction company's portfolio, or perhaps an individual project. So let's just go ahead and zoom in on this one particular dashboard. The same project we were just looking at, the same source of data. So we're repurposing data. We're not making copies and duplicates and then worrying about version control. We're looking at the same data repository, but in this case, repurposed for the cases and the uses related to construction logistics. So we still see some of the CAD information that's important to us. We still see some of the utilities, but we're also seeing permits, inspection status, location of workers, assignments to workers, and these are in potentially real time. Now, this construction project is done. This is referencing historical data, but this is the combination of all these various visual layers, sensor data, people's locations, inspections, and more in this case, a web browser-based environment. As I mentioned, the idea of bringing together your reality mapping, your reality capture information into a singular environment isn't just for visual purposes and isn't just so that context can be understood at a high level. But in the case of our own project, we were doing drone flights on a weekly basis. We now, as the owner of this facility, have access to the historical record. We're able to peel back the layers of the building. If perhaps we start to see a leak in the northwest corner, we can go back to this digital twin of our construction site, see the data that was collected through drones of any location on that site, and at any particular time, see perhaps flashing that wasn't installed correctly, or a roof penetration that wasn't sealed correctly through the library of images that exist on this particular construction site. We also have integrations between the location intelligent GIS capabilities, the CAD, BIM, and reality capture information, and schedule data, all in this case combined actually with a game engine to provide a level of visual fidelity, visual quality that really anyone could understand. So sort of gone are the days of needing to be able to understand a stack of 2D drawings and convert the complexity of multiple 2D drawings, but instead having 3D models that are very easily depicted, that are linked back to data, that are linked to schedules in these real-time game environment situations for construction. I mentioned schedule integration. I think it's very important to call out integrations with tools like Oracle P6 or Microsoft Schedule or Asta Power Project, or really any tool that can output an XML file of a schedule. We've created and open sourced the utilities that allow schedules to be connected to the GIS features so that one can visualize how a scheduled project is being delivered based on location. It really changes the way in which construction project management can occur when you see where your tasks are occurring, where your work breakdown structures and individual tasks of those line items that typically occur in a Gantt chart can be visualized on a map. And whether that map is an entire city or that map is an individual construction project, that element of location combined with schedule really changes the way in which construction project management can occur. And what's occurred to me not too long after joining Esri, like I said, about 5 years ago, my world was all about CAD and BIM and schedule management and bidding tools, and GIS was very much on the sidelines. And when I joined Esri, my first thought was I'm going to be dealing with maps, and engineers are going to have access to these maps, and construction managers are going to be better off because they're going to have these 2D and maybe some 3D maps to work with. But what I didn't realize was how important GIS is as a collaboration tool, as a means of getting information out of the tools that typically only a handful of people have access to. Your BIM experts, your CAD experts, your scheduling experts that then have to interpret static content. But GIS as a collaboration environment brings together people who typically might not have access to those engineering complex tools, but need to be able to make decisions based on engineering and complex data. So GIS as a collaboration platform really opened my eyes to its potential to do more than just deliver maps to a small group of people. Another area that's really become interesting to the whole range of AEC professionals is the idea of accessing verified authoritative data from various sources, whether it's an individual government like a municipality or a utility or a private sector entity who is collecting data like imagery. Esri provides a solution called ArcGIS Living Atlas, which is really one of my favorite solutions from Esri. thousands and thousands of layers ranging from earthquake location, hurricanes, weather patterns, deep learning models that we make available, slope maps, flood plains, drought intensity, building footprints, swimming pool locations, you name it. This library of data is available as yet another source of layers that can be brought together to serve the AEC professional as they're doing their construction management, their inspection, their architecture, engineering workflows. And as I mentioned real briefly, and I'll kind of take another minute or so and dwell on it, I'm using a solution called Story Maps, which is a no code, zero code. You can do a little bit of coding if you really want to push the limits of it, means of taking your maps, taking images, taking videos, taking text narrative, and bringing it all together to help with storytelling. So here we're seeing sort of an inception experience. Within this story map, we have a little video of the story map that I just walked you through, where hopefully you come to understand that this is an interactive environment made up of GIS data layers brought into a map, multiple maps in this case, made available to help tell a story. In this case, the story is how important GIS is for construction management. Another example that I think is really compelling is from our Esri China office. This is an example in Hong Kong where you can see a combination of map data, personnel information, health and safety information, logistics data, BIM information, camera footage, seismic information, as well as environmental conditions like temperature, air quality, the current temperature, traffic location, all brought together into this construction dashboard. And then finally, I think in this little example here is this idea how GIS, although many people might think of it as a planning tool early in the AEC workflows, perhaps an engineering application to help understand existing conditions. Hopefully I've shown you here its capabilities as a construction solution, but then all of these data sources can then easily be packaged up to serve as a digital handover. Whether you want to call it a digital twin or when you call it digital project delivery, these features, these CAD information, these various layers of imagery that are generated from various heights and at various timeframes all become available to the owner. And I've shown you an example using Esri as the owner, and we're going to see some other great examples coming up. It's really a complete lifecycle management solution from the earliest stages of planning into design, into construction, over to operations, long-term maintenance, and even the decommissioning of projects, many examples using GIS as a foundation for this entire project lifecycle management. So with that, I might cut myself a little bit short here. Opportunity for you to provide us feedback. The QR code on screen there will take you to a really quick survey, and we'll connect you with me and my team. I'll also make sure that we have this particular URL shared with you. But like I said, we've got in this case for AEC workflows, GIS for architecture, some common workflows, integration with Rhino for real estate, GeoBIM, a product that brings together the Esri online environment with the Autodesk Construction Cloud and BIM 360 and various other story maps. So with that, I'm going to hand it over to Michael Lodes from HNTB, a company and individual who I've worked with over the last few years, who I know are doing amazing things at the intersection of GIS and construction and design engineering and architecture. Michael, all yours.
Great. Thanks so much, Mark. As Mark mentioned, my name is Mike Lodes, and I'm with HNTB. HNTB is an infrastructure solutions company, and we have offices and folks across the United States delivering transportation infrastructure solutions across a number of different areas, like highways and DOTs, transit, tollways, and aviation. So my role within HNTB is I lead a team of professionals who do geoanalytics. We focus on really using the GIS data and doing some planning or some analytics to support data-driven decision making or data-driven design, all things like that. And today, what I really wanted to do is talk with you, give you a few examples of how we use GIS to support a number of different transportation asset management applications. And specifically, I want to talk about a success story that we've had with one particular program in the state of Michigan. So with that, I'll launch in here. You can see I've got this presentation titled "Getting Off the Ground with an Off-the-Shelf Solution." And really, the way I like to tell this story is the program that I'm going to talk about is we started with using all tools that we already have that were commercial off-the-shelf tools. So I'll get into that in a few slides. Off the top here, I wanted to share with you just a couple of examples of maybe the more exciting 3D type applications of different GIS and 3D CAD BIM things that we've done. This is an example of a 3D modeled bridge. It's actually showing in GeoBIM, like Marc mentioned, and it actually incorporates 3D CAD data from both Bentley as well as AutoCAD sources, gets pulled together into an Esri solution, and it really helps. It has really helped support the team's monitoring of an existing bridge while another bridge has been built on the side of it. So you can see some of the sort of asset management aspects here of being able to see manuals and kind of cut cross sections into the design. It really brings a lot more visibility into some of the 3D design there. And then the team has also used that to support the construction process. So really kind of supports a number of different elements there. Another kind of exciting kind of visualization that our team has used to support different type of transportation work is really to think about construction phasing, right? So this example is showing, actually it's a 5D model. So we've got 3 dimensions, and then we've got cost and schedule as well incorporated into this. And what this really helps us to do is visualize what are the constraints that we might encounter as we go through construction, right? So this schedule aspect allows us to use a time slider and show which aspects of the infrastructure is going to be built at certain time periods. And you can also see that kind of cumulative cost curve to help us understand the financial burn and kind of where we should be along the way. So again, this is a really exciting application of GIS and 3D, GIS, BIM, CAD data, all of those things kind of coming together for a really exciting solution. And then the next example I'll share is, again, really kind of on the cutting edge of what we're doing here at HNTB for some using GIS and asset management and infrastructure management. This is an application of using kind of drones or UAV to support the inspection of some very tall structures. In this case, it's a communications tower, and we have an automated Skydio drone that we use to collect the data. You can see the purple dots in the image on the left are the locations where individual JPEG images were taken, and it also shows the 3D mesh model that was rendered after the fact, right? So the drone goes around. It collects an immense amount of imagery as well as LiDAR data. And then there's some processing in the background to support a 3D model being created of that asset. And then this viewer allows inspectors to do a visual interactive inspection without climbing the tower, right? So we use this as an early warning or as a way to kind of get that first pass to see if there's any specific areas of concern, and then we follow it up with a tower climber or something like that if there's anything identified of concern. So these are some of the really exciting things, like really the more flashy things that we can show that we can do and provide a lot of value. And what I really like to focus on the last like maybe 10 minutes of my time here is I really want to talk in kind of more practical terms about how we can get started in using GIS as a tool to support asset management and of a number of different asset types. So the example that I have here is specifically focused on some ancillary structure assets, but it could be utilized in a number of different transportation assets, such as bridges or other assets. So as I mentioned at the beginning of my time here, this presentation is really about getting off the ground, right? Maybe you're just starting your asset management program, or and you're thinking about where do you want to go? How do you get started? So I like to use this image example of this plane taking off, right? We know that we want to get up in the air, and we know we have to start on the runway there, right? What's not shown here is all the stuff that happens beforehand, right? So that's some of the things that I'm going to walk through today. Not all of the technology tools, but really how you can get started on building a GIS asset management program. So I'm going to kind of walk through these three different areas of how we got this program started. Specifically we first had to plan a route, right? We then had to do that equipment check, right, before we were ready to take off. And then we finally got rolling and kind of had that lift off there. So looking at this sort of idea of planning the route, the first thing we needed to do was really think about what assets we had, and where were they located, and what was the information that we wanted to collect about them. And what we decided to do was kind of do a staggered rollout of inspections over the course of a few years of this ancillary structures program in Michigan. So you can see we identified maybe 4 high priority assets that we wanted to start with: the culverts, retaining walls, and the sign support structures. And then we phased in other asset types over the course of a few years. One of the things that we found was very, very helpful in developing this program and figuring out how we wanted to manage these assets was collaboration across a number of different stakeholders and partners. So this graphic is really showing at the top, what are the things that we really where do we want to get to, right? We want to get to system state of good repair. And these blue pillars are showing all the different stakeholder partners that we have coordinated with and are critical for coordination with to actually get the asset inspection data out of just a database and into the hands of maintenance folks or people who are planning projects so that it can be used in a meaningful way. Some of the other things we did early on in this program to support a robust, well-supported program was we knew we needed to have a good documentation of where we were going and how we would get there. So the way that we did this was by developing this manual we called MIASIN. This is the Michigan Ancillary Structures Inspection Manual. And again, I know this isn't GIS in particular, but this is really the framework. This is the roadmap that we developed internally as a program that helped us support to support the decisions we made and standing up a GIS database and getting the inspections in the field. I'll just note this is a publicly available document and website. So if you just search MDOT ancillary structures, it'll probably come up as one of the first few records. And feel free to take a look at the manuals and the other resources that we have there if you're kind of going down an ancillary structures asset management journey. We also knew that this is a pretty large program. Some of you guys may have varying sizes of program, but in this program, we knew we had around like 70,000 assets or so, and we're going to have 4 different firms out there inspecting assets. So a training program that supports consistency of ratings across different inspectors and firms was critically important. Even the best technological tool isn't going to help us do that when there's so much subjectivity and that can be inherent in some of those things. So now we get to kind of the fun part, right? So we've kind of set up the program, we've developed, figured out what we wanted to collect. And then we kind of started thinking about how would we actually collect this? So, we started thinking we would use a mobile app, and we landed on the Esri field maps application for this one. And we paired that with a database in ArcGIS Online. This is the cloud hosted Esri solution. And some of the data sets were also on premise within the Michigan DOT IT infrastructure in their ArcGIS enterprise. All right, so this makes up the bulk of how we collected data on a day-to-day basis and how we stored it. We also had some options to, very quickly and easily be able to spin up some different applications, web applications for reviewing the inspections as they came in and providing some high-level results out to stakeholders. And then the last part of kind of our collection approach here was to think about what we need to do in terms of some Excel exports and some things in SharePoint for better accessibility for the team. So this is kind of what we landed on in terms of our collection approach and how we would actually get going. I think most of you are probably familiar with the way this sort of looks, but you can kind of see an example there on the left of most of our inspectors are out there with a tablet or a phone using this field maps application and collecting data. It's very readily available to them and it's going really, really well. One of the important things that we worked on in this program was to, we had this flexible framework. We used the Esri database, which gave us a lot of flexibility to develop our own database model and schema. And so through this, we had a lot of iterative changes to the database as we identified what we wanted to collect and what we, maybe things we thought we wanted to collect, we identified were challenging out in the field. So we kind of went in this refinement process and got feedback from field staff and SMEs. And we know that the client, Michigan, wants to move to an enterprise asset management application and not solely relying on the Esri platform. So we'll be moving. We know that when we get there, we'll have a really mature data schema. I've got just a couple slides here showing some of the different ways that we've been reporting some of this information out to the different stakeholders. So this is a dashboard that's really more focused on maybe like high-level planning or identifying those worst areas of poor conditions, things like that can be used to help prioritize maintenance or capital programming. And then we also were able to develop a more in-depth solution that allows teams to really get in and inspect and investigate some of the details of the inspections, including detailed photos and all of the attribution that comes along with it. Some results that came from this is we were able to get people engaged in the application and the data environment to really reduce the amount of time it took to address some of the findings that were identified out in the field. So you can see we started almost a year taking to get this addressed, and have moved into more of about a month. All right. And then the last thing I'll just share with you as some takeaways here is we were able to get this program going using a COTS or commercial off-the-shelf software approach. And here are some of the things that we really found were helpful, right? This has a familiar approach. We had a lot of people already using some of the Esri apps, so it wasn't a big change for them to go ahead and jump in and use them for a different asset type. We were able to collect an enormous amount of high quality inspection data without purchasing any new software. We also didn't have any kind of delays due to that procurement or IT process. So we were able to get up and running really, really quickly. We've maintained the full control over the data schema, like what fields we have, and we can change that as needed. And really it helps us. We have everything we need. We have all the apps and things like that we need. And we know that future goal of moving to an enterprise asset management software, we know that we have that mature schema where we're not going to be needing to make costly updates to a more enterprise customized application. So thanks for listening today. If you have any questions, I am more than happy to discuss them with you. And I know I'm going to be David Grafton is going to be coming on here in just a moment to continue the conversation. So thank you for your time and welcome, David.
Yeah, I really appreciate that great success story, Mike, as well as Tony for hosting it, and the great overview of all the awesome Esri tools from Marc as well. So just to introduce myself really quick. I'm Dave Grafton. I've been part of the Geospatial enablement team here at Bad Elf for 3 years, coming out of ASU. Go Devils. And what we do over here is hardware initially, but now we're really moving to the training space as well. We really like to help organizations get their system of record, as we like to call it, just get that started off the ground, get the ball rolling for you all. Hopping into a brand new process, especially transferring from a manual paper and pen inventory over to a digital process, can be somewhat intimidating. So yeah, we're here to help hold your hand, or at the very least, hopefully from this webinar, me along with other presenters educate a little bit what's possible out there, just teaching you what you can exactly do with your organization, state or local or otherwise, to really start enhancing safety for the general public, and really just streamline your process and making everything more efficient. So let's go ahead and launch the poll just to get a quick idea of who's out there in the audience. Always like to make sure what we're covering is relevant for you all. Thanks for launching that. So just to give a quick summary of what we're covering today is that we're going to cover the benefits of converting to a more high-tech digital system. It's really crazy what you can do now with a relatively low cost and training relative to just 10 years ago. So that's really exciting stuff. Covers how you can use drones for inspections and inspections for it's looking at bridges, imagery, using that, implementing that into your system. And finally, let me share my screen over here as well. Sorry, I had to pull up on the screen. And finally, just going ahead and just how to get started. How do you really initialize this whole process? So just a quick background, there's over 600,000 bridges in the United States. So probably many in your area, just statistically, unless you're living in, a very flat area without much infrastructure, which I doubt there's too many experiencing those conditions. But many are exiting service life. So it's more important than ever that we really implement a very solid system that can share knowledge and data with stakeholders, so everyone is as informed as possible when making their decisions. So legacy paper and pen inventories, they can limit that accessibility and the knowledge of exactly what the conditions are looking like at the time. So there's a major need to educate the public as well as the internal stakeholders, especially people making major decisions as far as funding and project coordination, just giving them the most accurate and up-to-date data possible, and really limiting any roadblocks and timelines, reducing timelines to make that happen as quickly, as efficiently as we can reasonably do. So obviously, safety is a very key component over here. This is generally the overarching theme of why there are so many regulations, why we are doing these bridge inspections and inventories. For example, there's been a couple of bridges incidents over the past couple of years from things breaking down, and it can lead to loss of life. So it's just important as we kind of dive into the minutia here, just keeping in mind how important this all is for the safety of the general public. It could be you, your friends, your neighbors. So it just kind of provides additional motivation to really implement this and just stay on top of it as much as you can. This also provides funding for your local organization, tons of federal, state grants out there for this kind of work, and we want to make sure we maintain compliance so there's no issues in obtaining that funding or budgets. So the primary components here is we really want to track structural integrity and material quality. So that means implementing a database for organizing this whole asset inventory so we can evaluate the conditions, coordinate maintenance planning, etc. We really need specific measurements for these databases. You can see right here on the right side of the screen that this can include many different components. So definitely want to make sure you have this organized and a good best practice and a good workflow plan so we can track these as effectively as you can. These aren't all necessarily required, but you definitely want to make sure that you have at least a plan to start tracking all of these different metrics. What do we do with all this information? You can use this for obviously coordinating projects and distributing budgets, funding to specific bridges and areas. But we can also use this for evaluating change over time, sort of track trends, conduct some advanced analysis. This allows us to create reports on demand. In fact, it might not even require any effort from your organization since this is all managed digitally. If this is shared transparently with the public, they can actually go on and create their own reports in some cases. And even beyond that, you can import this into BIM for analysis, perform a hydrological assessments, as well as some awesome 3D sort of point cloud maps that really allows you to visualize exactly where the issues are and exactly what the status of the various bridge components are. All right, so let's go ahead and close that poll and just do a quick review on that, if you wouldn't mind. So it looks like many of you are not implementing a GIS solution for your bridge inspections and maintenance. No surprise here. That's why you're interested in this. So hopefully you learned something today and get inspired to begin that process. And looks like many of you are actually using a GPS for your data collection. So I'll just cover a quick overview of that, just some of the major considerations when you are starting to integrate GPS into your bridge inspection systems. So the benefits of moving over to digital, data entry is going to be far easier with these digital dynamic forms, especially if you're using an app like ArcGIS Field Maps. You can do a lot of automation, real-time data checks. You can implement domains and checklists just for its real-time validation and QA effectively. Out there in the field, you don't have to worry about people making typos, maybe forgetting to fill out a certain aspect of the form. If it's raining, don't have to worry about the paper getting wet, smudged, data entry errors, etc. It just really streamlines the process because you take the whole transfer workflow out of the equation. You're just implementing straight into the system, and as long as you're connected to the internet, it's syncing straight to the cloud. And actually, in real time, you can have somebody in the office checking and coordinating workflows, making sure everything's looking good, as well as reviewing your own work as soon as you input it. So extremely advantageous, especially when you start implementing GPS and you start having to actually stake out, navigate back to those specific problem areas instead of just having a very generic coordinate of where the bridge is located. You'll have the exact coordinates of those specific locations. Photos as well. Using in the past with your individual manual photos, you would have to attach GPS metadata, which is if you're just using the camera, questionably accurate. It requires you to tag photos, associate them related with specific records. So just having it all in a single system just really reduces the chance for making any errors. And finally, all of this information is going straight into your digital system, and you can choose to present that however you like. Awesome example here from our local ADOT, Arizona Department of Transportation, where they have this amazing dashboard where you can click through, see what the last inspection, maintenance, locations are, all the bridges, and seeing these awesome aggregated stats of exactly what the bridges are looking like, and even filtered to specific areas if you want to just check out to see what these look like in your township, etc. So very powerful tools and definitely worth implementing. So what are the considerations with GPS? So GPS has come a long way in the past decade or so. If you're just using your phone or tablet like you would in your car, that's awesome for very general locations. That can definitely help you just track the location of the bridge in general. But then when we start wanting to track specific locations of exact defects, we need more accurate solutions. So that's where the very accurate GPS of the modern day come in. The two major categories would either be survey grade, where you're connected to an RTK system, and you can use these for elevations. Horizontal elevations are typically 1.5 to 2 times more accurate than vertical elevations. So especially with bridges where orthometric heights are so important, we really want to be as accurate as we can. And you can get 1 centimeter, 2 centimeter accuracy by simply picking up one of these units, connecting to your network, and then just connecting to your phone and using an app like Field Maps or whatever your solution of choice is, and start collecting extremely accurate data without being a registered surveyor. I still recommend going through the only using people that are registered or licensed for whatever application you're doing, but it's more accessible than ever. You get with our mini, you can get sub-foot accuracy, which is great for just inspection locations, just in the palm of your hand. And there's plenty of survey grade receiver, such as our Flex, that offer that as well. So just a quick overview of the bridge inspections. Again, elevations really come into play here. However, with bridges, you have to have the unique challenge of multi-path air. If I go back to the previous slide over here, you can see that with your phone, it's experiencing a lot of different errors, mainly from the atmosphere, and that can really cause a lot of problems with your exact location. The other main one is multi-path, where signals are bouncing off of objects overhead. So just be very mindful of that. When you are collecting data, you will not get as good at accuracy directly under a very thick concrete structure like a bridge as you otherwise would in the open area. And we'll cover that really quick in the drone section. So yeah, again, technology advances come a long way. Vertical accuracy is very achievable now in the very simple setup process. It literally just takes you a minute or two to get going, as long as you're connected to the internet. And it's actually so accurate, we can measure real-time oscillations and vibrations with the GPS. So we're talking even sub-centimeter accuracy in some cases, and really far beyond where smartphones have been. But giving credit to smartphones, there's actually projects out there using the accelerometer and GPS in consumers, commuters, as drivers, that actually use that to measure oscillations and deformations of the bridge over a time of day with certain traffic. Because we have so many of them, we can average it out and actually use this as part of the analysis too. So the technology available now is really amazing. We can also use artificial intelligence to go through our photos and automatically identify defects. So lots of options out there to do some really advanced stuff, again, without much training, prep, or investment. Drone inspections is where this gets really exciting. With ground control, you can ensure that these point clouds you're creating, this imagery, this is basically what ground control consists of, is placing a target on the ground and then shooting that with your high accuracy GPS. And it's sort of, you can imagine a map, if you're trying to map to a real location in the world, the ground control points sort of act as a pinpoint to make sure that your data is actually, where it was allegedly recorded. And even beyond that, if you're doing real-time corrections just straight to your drone, it's still not a bad idea to throw a target on the ground, as you can see in the bottom right with that sort of square, to just verify that the data is as accurate as it says. It's always good to perform checks and balances, just like you were doing in real time with your phone. You can even do this in you can even inspect in real time with the first person view. You can throw on a pair of goggles and you can just go straight up and zoom straight to the bridge. You don't have to throw any harnesses or anything like that. You get some really close-up views, very high resolution, and just look at it in real time instead of having to go through a few photos and evaluate those after the fact. Just finally, when you are doing these drone flights, just make sure you are FAA Part 107 certified. What the 107 certification consists of is just drone best practices and just ensuring that you're not putting anyone in danger. This means flying under 400 feet. You don't want any people underneath the drone, and just in case anything goes wrong, hopefully that doesn't happen. And just making sure you're flying in good conditions as well. Over here in Arizona, it's 115 degrees. You're not getting a lot of lift, and your battery's not lasting very long. So you want to make sure you get up plenty early before you start performing any of this. So again, Part 107 covers all of this. And then finally, how do you get started? ArcGIS Solutions is a great place to get started. They have a lot of ready-made templates, plenty of consumer-grade GPSs out there available for purchase, just like the Bad Elf. And there's not a huge barrier of entry at all anymore. With all the fantastic tools and the success story given by Mike, you can see it's easier than ever to start performing these advanced processes. You don't have to be a tech whiz or anything like that. With ArcGIS Solutions, it gives you a standard template with all of everything you need for compliance, but you can easily build off of that. You have full control of everything, and you can easily build off of that template. Finally, just a quick recap of the two major kinds of receivers. It's going to be the Bad Elf Flex. That's going to be your survey grade kind of receiver. Survey grade receivers will give you accurate elevations, while the GIS or mapping grades of the smaller ones like the Mini, that can be just held attached to your tablet. It frees up your hand. It's much more straightforward as if you're just doing inspections and whatnot, and you don't need that absolute accuracy, but you can still connect to a network and often get sub-foot accuracy for easy, stakeouts and navigation to get back to the defects when it is time to either inspect them again or perform maintenance. So so I appreciate everyone's time, and I will go ahead and hand it over to Scott. Please let me know in the comments if you have any questions. I appreciate it.
Yeah, hi, David. Thank you. Hello, everyone. I think that was some good information. It really set me up well for what I'm going to talk about. I'm going to talk specifically about bridge inspections and Bentley's bridge monitoring solution. So let me go ahead and share my screen here. And you should be seeing my screen. So my name is Scott Becher. I'm a solutions manager for Bentley Systems. And what that means is I spend a lot of time working directly with users, getting feedback on our solutions and basically taking that back to our developers and making the necessary improvements and really, making it more valuable for our users. Over the last 2 years, I've been working specifically on our bridge monitoring solution, which is really just a fancy word for sort of a grouping of our products. So we've got a wide portfolio of products, and we bring appropriate products together to provide a solution and really just meet the customer's needs. So my hope today is that in this presentation, I'm going to kind of show some of the feedback that I've gotten from users. It's DOTs and other owner operators and engineering consultants. The insights that they've given us, the value that they've gotten, sort of the friction points that they've identified. So we'll go from here. So starting off, I mean, when we designed the solution and through the process of implementing it or trialing it with users, we identified some common challenges. I won't talk through all of these. I mean, I think some of these have already been covered in here, but a lot of bridges in transportation networks are nearing the end of their useful lives. And that makes these inspections even more critical to be accurate and to provide those insights where we can provide the necessary maintenance and rehab projects. The workflows are disconnected. So a lot of times there's a lot of files, there's a lot of information that's generated throughout the life cycle of a bridge. That could be historical inspections, it could be BIM data, it could be construction progress photos. And those are all historically been in different places, and it's tough to access to the point where it's too much trouble to even access them. Complex and signature bridges that require detailed inspections and monitoring. Some of the feedback we get is that these large cable stayed bridges, these signature bridges, there's so many stakeholders involved. There's consultants, there's sub-consultants, there's contractors. They all need to access that data. They all need to contribute to that data. And it can be difficult with that much information. So, and then finally, last but not least, making it safer, safer for our inspectors, but also safer for the general public and our motorists. Too often we see these sort of tragic headlines of a bridge collapse, and no one wants to see that. And I think that through digital automation, we can move towards making those. Moving away from sort of reactive maintenance events and more towards a preservation strategy. So at Bentley, we're a digital company, we're a technology company, so we have to say, okay, what can we do to address these challenges? And just to quickly talk through these, one thing we say at Bentley is visualize everything in a single pane of glass. So your monitor, all that information that's in data silos, we can bring that so that it's easily shareable, easily accessible to all project stakeholders. Mitigate excessive access risk. So it's really about moving as many of those inspection hours in the field to in the office. So we're not going to eliminate on-site inspections, but if we can do more in the office, it's going to minimize risk. Leverage photorealistic models. So photos have been used from drones and handheld cameras for bridge inspection for years effectively, but you can sort of take the next step and build a model to where you can get that additional context of where your photo is and the georeferencing, the GIS data that's so important. And then once we have that model, we can start to use really neat tools like AI. David mentioned some of these. I'm gonna go through in detail some of our defect detection, and it's not just about eliminating tedious tasks. It's about improving consistency and accuracy of that detection. Change over time. So once we have sort of a history of reality models, a history of defect detection, and we've got it all in that single pane of glass, we can make it easier to compare those areas that are really starting to deteriorate, maybe deteriorate at a faster rate than other areas. And then engage real-time insights, sort of back to single pane of glass, bringing in IoT sensors. So some of the signature bridges, they're loaded up with instrumentation for structural health monitoring. We can bring that in so that, again, all project stakeholders can see all the information and contribute to it as necessary. And so in working with the users, as I said, we not only worked with our technology and our tools, but it was very important to sort of establish workflows and workflow standards to make sure that we're not totally upending the existing workflows, because anyone who's ever adopted new technology knows that if you have to do basically 2 steps in parallel, it's probably going to fail. So we wanted to make sure that our tools could be easily integrated into existing workflows. And so you see here the high-level steps. I'm going to go through each one of these in more detail, and I've got some videos, but this shouldn't be too eye-opening for anyone. And basically we want to go out and capture that raw data, whether that's photogrammetry or LiDAR, could be GPR data, and that's sort of the field work. Then we bring that back into the office. We build a reality model. We integrate design data, historical inspection data, and we build a beautiful looking model that's easy to access, easy to navigate. And then in step 3, the work we put into 1 and 2 start to pay dividends. We can do inspections, we can take annotations right on the model, we can run that AI defect detection and get the sort of the dashboard views out of the IoT sensors, and set the alerts. And so we talked a lot about drones, and I will say This could involve a UAS crew that goes out. It can involve a survey crew that goes out to set ground control points. And I will say that sort of, in my time working with users, this is probably one of the most important steps. And I mentioned that I was going to discuss sort of the friction points. This can be one of the hangups, and it's really imperative to put the time in to create a quality model, because if you don't create a quality model and it comes out looking like melted ice cream, and then no one's going to have confidence that they can really sit behind a monitor and get a good feel for the as-is state of the bridge. So I'm optimistic about that. I think the drone manufacturers are doing some work with AI, and they're improving the acquisition methods so that it's easier for those drone crews to really get quality models. So once we get all that quality data, we can take it back to the office and we can build that photorealistic model. You can integrate it into a map view. So, certainly maybe you're managing a network of bridges, but not every bridge is going to need a photorealistic model, but it's a bridge that still has an inspection history. It's got data associated with it, and you want to be able to manage it. Like I said, in that single pane of glass, you can do that. And then for your larger signature bridges, you can send the drone crews out, create a model, and layer in all that additional data. You can even layer in BIM models. I know Marc talked about that. And one of the advantages here is you're bringing in a BIM model with all the properties, and maybe that's not necessary for a bridge inspection, but it could be applicable in different other areas where maybe there's individuals who want to be able to access that data that's in a BIM model, but they don't have familiarity with navigating a design authoring program like AutoCAD or MicroStation. And so they can access it through the web, and it's layered in with all the reality data and all the other data that's associated with that particular bridge. So again, sort of the theme here is bringing in everything into one location and making it easily accessible to all project stakeholders. And then when you've got the model built, you've got everything pulled in, that's when you can do the inspection. And sort of a remote inspection where you can zoom through the bridge, fly through the bridge, click on areas of interest, create an issue. You can use the photo navigation feature. So previously you may have opened up a folder and kind of scroll through photos of a bridge that were taken by a drone, but you didn't have the context and that sort of side-by-side view of, where is this photo located? And then I should mention, I want to be clear that, we're not suggesting that remote inspection is eliminating the need for an on-site inspection, but I mentioned workflow, and a lot of the users that we're working with have implemented this tool as sort of a pre-inspection tool. So what they will do is send out their drone crews, create the model in the office, and then give it to a set of engineers or inspectors who may be not as experienced, and they can take a first pass at it and identify some critical areas, critical spalls or cracks. And that way, when the senior inspectors do go out in the field, they can better plan their inspection, so they can better make better use of the equipment on site. They're reducing the lane closures, they're reducing the impact on motorists. And additionally, they can when the senior inspectors go out, they can have that model on a tablet. They can go to each one of these defects, they can amend it, they can take photos, they can delete it, they can make new issues. So it's really about, again, like I said, shifting those high risk, expensive inspection hours in the field to the lower risk, less expensive hours in the office. And you saw here too, there was a couple of capabilities where you can attach PDF files of design rehab recommendations. You can also export the information with the geo-referenced issues. So again, making it easily accessible to all parties involved. I mentioned AI. What you see here is an example of a bridge where artificial intelligence model was run for crack detection. And some people might say, well, okay, you've highlighted the cracks. What good does that do me? Well, once you highlight the cracks and you create a CAD file from that automatically, you can start to extract the geometry. And so it makes it easier to compare over time when you have a tabular view of all your cracks. But also, I mentioned consistency and accuracy, and that's not to say anything about inspectors and that they're not producing accurate data, but you can imagine if an inspector is working out in inspecting a irregularly shaped concrete spall, and it's extremely hot and they're dodging cars that are whizzing by, and they're doing with a tape measure, compare that to a computer that's basically identifying those spalls by looking at the pixels of and identifying that area. You can start to see how you can provide a more accurate accounting of the defects and really a baseline for starting an inspection and going out. Like I said, the senior inspectors, they can pre-plan those inspections when they do have to go out in the field. And just really quick, I'll kind of wrap this up with sharing a case study. So this was in St. Paul, Minnesota. This is the Robert Street Bridge. This is Minnesota DOT. And we worked with a couple of consultants who performed this inspection. And what they found is that using these tools, they saved over 30% inspection hours and fees. So you can imagine the impact that is on the dollars spent and the impact on traffic. They're not spending money to close lanes. They're not causing disruptions in traffic. So it was a win for everyone. And then the feedback we got from the owner was that this was sort of a projection that they expected to see a minimum of 20% construction savings. So this inspection was done as part of a identification of defects for rehab and maintenance items. And what they said was that previously they would be working with a lot less information. And so they were sort of forced to make overly conservative decisions. So for example, there may be a delamination area, but they didn't know how big it was. And so when they go to a contractor for repairs, they make an estimate and it's always going to be overly conservative. But this tool with the additional information gave them the confidence to really hone in on exactly what repairs were needed and better allocate those resources. So again, I just kind of wanted to wrap up with that. And I should say there's a YouTube video. It's sort of a marketing video, but it highlights this use case. And you can hear directly from the inspectors and the owner and operator that worked on this project. So thank you for your time. And with that, I think I will invite my co-presenters back onto the stage for some.
Okay, while we wait for the presenters to come back on board, I'd like to open it up. First, I'd like to thank our panelists for the presentation. Obviously very informative and great information. I'm sure a lot of you have questions. So all of our panelists are back on stage. If you have any questions, please type them into the chat and we will basically just go through them one by one. So our first question is, curious which drones would be utilized for bridge inspection. So if our panelists would like to tell us a little bit more about their thoughts on which drones would be ideal for this application, that'd be great.
Yeah, I think I could hop in on that. So just to speak more generally, there's two major kinds of drones. There's going to be your fixed wing as well as your quadcopters. You're definitely going to want a quadcopter for bridge inspections just because you need to be able to hover while the fixed wings ones are constantly flying, effectively like airplanes versus choppers. So At a very general level, that's what you want. You also want a drone with a solid IMU system, basically good accelerometers, inertial measurement, just because if with a lot of drone apps, you're actually flying you chart out your path. And when you're under a bridge, that GPS, that multipath error I mentioned earlier, really comes into play. So your drone may have issues with sort of navigation and whatnot. So without mentioning any specific brand names, yeah, again, quadcopter, multipath, and ensure it has a solid camera so you can leverage systems like Bentley has with their AI detection just to ensure it's not working with some low resolution, low quality photos.
Any other response from our panelists? All right, next question comes from Ben. How do the inspectors, either in the field or virtual, using the iTwin experience, hand off to civil engineers which need an ORD model for their digital delivery?
Mm-hmm. Yeah, this is a great question, and we launched this solution about a year ago, and one of the things that I mentioned early on is it's sort of a grouping of different products. So you mentioned ORD and you mentioned iTwin Experience, so I can tell that you are familiar with the solution. One of the things that we're still sort of developing is that handover. So we know that sort of in the project life cycle, the idea is that those recommendations are made, or those defect areas are identified, and then that can be basically exported back to ORD. And I'm going to be honest, it's that workflow is not completely worked out. But that is something that sort of an export to an IFC file or a DGN file is certainly in the works. So I guess the answer is stay tuned for that.
Sounds great. Thank you. Next question. Scott, you had mentioned a YouTube video highlighting this workflow. Is it possible to share that link?
Yes, definitely.
Okay, great. Do we have any other questions in the chat? We have time for more questions, so if you want to type those in, please do so. We're actually going to run one more poll before the end of the webinar, so in a few minutes you'll see that poll pop up. So if you don't mind answering those questions when that poll pops up, and there it is right there, please take a few seconds to answer that question. So question I have for the panelists is, how accurate is your AI crack detection?
Yeah, I think I'll take that since I'll start with that since I took the AI. But it's a great question. I will say, Bentley's not the only program that does AI detection, but with ours at least, you can change the sensitivity on the crack detection. So you can set it to where you can detect more cracks and probably get some false positives, or you can detect less cracks and maybe miss some. But I will say that some of the users we've worked with, they have done sort of ground truth versus the AI on crack detection. And for the length of the crack, it's pretty accurate. It's 90%. What's a little more challenging is the width. You can imagine that if you have a 3-foot crack, it's not going to be a uniform width all the way along. So you have to sort of train the AI if you're going to take the max width, the average width, the minimum width. And so that's something that we're continuing to develop, and a lot of users are providing great feedback because some of the feedback we've gotten is that some of the inspectors aren't even consistent across the board if they're going to measure max or min or average. But I think the value today in width is at least well, they can certainly get the length of crack, and that's pretty accurate. But then also sort of comparing across time or comparing across spans. For example, you could run detection on multiple different spans on one bridge, and you can say this one particular span has cracks 30% more than every other span. What's going on? We need to take a closer look. So it's not necessarily about each individual crack. It's about sort of the collectively looking at the health of the bridge.
And I'll maybe just chime in there as well. I mean, it's a situation where the quality and type of reality content that you're capturing is a big variable, in addition to obviously the software that is then detecting that. So you can imagine a satellite image or a fixed wing image of a situation versus a drone that is getting up within inches of the actual cracks and existing condition. The closer you are, the higher fidelity, the higher resolution, whether you are using, LiDAR versus, multiple photos, whether you're using video. It's a
Rooms turn icy cold instantly with
garbage in, garbage out, I guess was what I'd end my comment on.
Yeah, and I'd just like to use that to highlight the importance of keeping good metadata, just tracking whatever metrics you record, whatever is in your database. If you can, just try to record how it was collected for GPS specifically, just maintaining the accuracy, the correction source. It's not directly related to AI, but metadata in general is definitely a key priority as you're creating your system.
Great, thanks for those responses. What about incorporating terrestrial LiDAR scanners, for instance, Naviz or any of the others?
Yeah, and in the case of Esri's solutions, whether the images are collected from satellite, fixed wing, helicopter, drone, or ground-based, it's about file formats, that data formats. So it really does not matter to us. We've got various products, capabilities, image, reality mapping solutions, reality mapping functions that bring in data from any level of capture. I imagine the same is probably from most platforms these days.
Yep, I would agree. We can handle many different types. I guess for bridge monitoring specifically, most of our users are seeing more value in photogrammetry, but we're moving more towards LiDAR for asset inventory. And there's some pretty exciting things about using AI to automatically detect guardrails and lane markers and stuff like that with scanners.
Okay, thanks. Question from Ben. Are DOTs specifying these systems into their contract procurements? And which DOTs other than MDOT are using these workflows? And just, Ben, there's about 8 M states, so I'm not sure which one you're referring to, but in Missouri, it's MoDOT, so maybe it's not Missouri.
And I've worked with Montana DOT. I know that they're doing a lot of reality capture. Caltrans, definitely. They have their own, I think, half a dozen vehicles with extensive reality capture they're doing themselves in addition to requiring it of their engineers. So I think broadly saying our DOT specifying these systems, I think it's more about performance requirements, quality requirements, and workflows than necessarily requiring reality capture per se. At least that's what I've seen.
Yeah, I would agree with that. I mean, I think that there's several DOTs we're talking to that are sort of interested in it, but I mean, the way I see it is, the consultants are somewhat driving this because they're getting so much value out of it that they're almost doing the job to present this to the DOTs and say, we can reduce the inspection time, we can reduce the impact on traffics. So I don't think we're to the point that they're specifying it. I know Nebraska is specifically looking at reality models, and they're using them pretty heavily. There's some other states, West Virginia, Kentucky, yeah, like I said, I think the consultants are doing a lot of the driving right now versus sort of being specified to provide that.
Yeah, Scott, I would agree with that from the consultant perspective. I mean, we would evaluate as we're kind of thinking about our approach for the project. We would evaluate if if collecting that data and utilizing it makes sense or not. And in many cases it does, and doesn't necessarily add any cost to the project, right? Because there are so many efficiencies gained from having that data and processing it in really efficient ways. So I know that we are often suggesting and proposing it, and it tends to resonate really pretty well for the projects that it makes sense.
Great, thanks. So what are some of the best ways or formats to bring CAD and BIM into GIS? And what are some of the gotchas to consider?
I'll start with that. In the case of ArcGIS Pro, which is Esri's flagship desktop solution, we bring in Revit files directly. We bring in DWG files directly from various AutoCAD-based formats. We're bringing in InfraWorks files, on the Autodesk side, in the case of Bentley, through FME, Safe Software, DGN files. I'm a big proponent of IFC. We have really jumped on the effort to make sure that ArcGIS is capable of bringing in, and we're contributing to the effort for IFC files in the realm of infrastructure. I can share a couple of links that give some best practices on the incorporation of CAD and BIM data into GIS, and another link that I think lists some 300 different formats that we bring in that include CAD, BIM, other GIS formats, other mapping data, OBJ files, FBX files. I mean, you name it, USD integrations. There's quite a wide range. I'll make sure those links get shared.
Okay, question from the audience is what we've discussed today and the things that you're doing, are they being integrated with the SNBI coding process? Anyone want to take that?
SNBI.
I can give a little bit of response here. So I think in some instances when we might use drone capture or other things like that, it would be a supplement to a hands-on inspection. So in some instances you might be able to still do more of a bridge, a national bridge inspection type approach. But I think that would be a decision, or you need to make that decision on that in particular situation. I think some instances where we've used drone imagery for bridge inspection as a consultant would be, maybe more of an impact, or if there was something identified like a serious critical issue, it might be outside of the normal routine inspection procedure or cycle. So we would use it to get that initial first look at any sort of damage.
I think we have time for one more question, if anybody wants to type one in. Okay, seeing none, I'd like to go ahead and wrap up our webinar today. I'd like to start by thanking our speakers. Great presentations, great topic, and very, very interesting, obviously, for all the participants. And very interesting from somebody like me who isn't intimately involved with this. Real quick, let's just go over our poll. We asked folks if they found if they were going to be more likely to use GIS tools for bridge inspection after this presentation. We had 83% say yes. So I really want to reinforce what our speakers did, because they obviously made the point and nailed it home. So we'll send out some follow-up information after this webinar. There are going to be more webinars on the horizon, so I'd invite you to join us for those. And with that, I would like to go ahead and close it out. We are going to be putting some of those links in the chat, so you'll see them popping up here in the next few chats. But with that, I'd like to say thank you, everyone. Have a great rest of your week. We look forward to seeing you in our next seminar in the series. Thank you.